Hi, this is a supplement to Straight Line's Executive Black Belt course, and this covers slides 90 through 129 in the week 3 of your binder. And this specifically is about process capability. Now this will be about an hour long, so it'll take a bit of time. What we're going to go through basically the notion of probability, and we're going to show you how to do this in a number of different mediums. One is just straight out counting. The other is using a program like Minitab or Excel statistics. And we're going to show you how to do all of that in a number of different situations. We're even going to show you once the classical way of doing it, which is using a standard normal table or a Z table to do it. Now, just to keep in mind, everybody, what we're looking at right here is, remember, we are solidly in the in the M phase of a project if we're going on the DMAIC, right? So we're talking about the M phase of a project. One of the last pieces of that is baselining. What is your baseline? And capability is a big part of the project baseline. Remember the whole discussion about the VOP? That is the control chart, right? As opposed to the VOC, which was we learned it as a histogram with a line through it, and we learned also that where we're essentially saying percent good and percent bad. Okay, capability is this part right here. It's this part right here. Check mark, buddy. All right, where we're trying to get the voice of the customer and try and put that into the perspective of a number that we can then either meet or beat, preferably beat at the end of the project. Okay, so let's go to it. When we finish this, you will be able to define and calculate capability for your key output variable. That's your Y. Remember, that's your output. So once again, just to take a quick look at that, we're talking about, just to make sure we're all on the same page here, we are talking about your output variable, your Y, your KOV, your output, whatever that might be. If you're on a call center project, it might be your average handle time, or it might be your one and done rate, right? First call resolution. If you're on a hospital, it might be the time that it takes you to do a discharge, or it might be your cycle time. If you're in an IT project, it might be the number of defects that you get each week. In any event, what we're going to talk about is how do we express that capability. Okay, and just to keep in mind, we are talking about when we're on the DMAIC time frame, we're talking about baselining the process. Okay, so what's the big deal about capability? It's really just another name for how do we put together, how do we look at if you recall correctly, it's just another name for the percentage of time that we get it right. In other words, the percentage of time that we meet or beat the customer specifications. Now those can be real customer specs. Like I grew up in manufacturing, we would have real customer specs. They could be performance guarantees. They can be things like that. They can be internal as well. They can be management goals. But the point is that how often does your particular key output variable, whatever you're measuring, meet or beat? How often does it meet or beat those stated specifications? Okay. Now, having said this, this subject has a lot of lore and history, and you'll see I've got a few of these things like highlighted. You know, there's this notion of something called CPK and PPK. Those are sort of like classical capability indices. We'll have occasion, capability indices. I'm not going to define those for you, but we'll have occasion to see those. And there's also something called Process Sigma. Now, because this is a Lean Six Sigma course, you're actually going to get some of that, and that's in essentially the next section in the next lecture. So we are going to talk about that. However, having said, both of these things, in my opinion, can easily be replaced. Most often, almost all circumstances, we can forget about these and we can put the percentage of time we get it right. Okay? And just so that we know, that's actually 100% minus the percentage of time that we get it wrong, right? So if we get it right 95% of the time, that's 5% we get it wrong. So either one of those is going to be fine. All right. So that's where we're going. And that's just what this says right here. Let's not forget about this. When we get a little bit lost in this particular section, let's remember that capability is either how often we get it right with respect to the customer or how often we get it wrong with respect to the customer. Either one of those is an acceptable way of expressing the capability of your current situation. Okay? Here's a couple of examples. Our billing defect rate is 0.12. That's 12%. In other words, we have a 12%, our current state is we have a 12% defect rate. That's a capability. We'll learn that all this other stuff, Process Sigma, capability indices, they're all just another way of expressing exactly that, percentage of time that we get it right or a percentage of time that we get it wrong. Okay. Reminding everybody that where we are is we're talking about capability. We're talking about voice of the customer. That's the back end of the process. And it really is what connects our outputs to our process and customers. Just a quick notion, we'll most often talk about a one-sided capability. And this is because simply in transactional land, in transactional land, like at a hospital or a bank or an insurance company or something like that, we often have one-sided specifications. Examples of these would be average handle time. An example of this would be average handle time. There I am, getting back to this. Average handle time. Okay, a good example of this would be, well, I don't want to handle somebody, well, actually, let me say discharge time, okay? So time to discharge somebody at a hospital, so discharge time. That would be a good example of a one-sided specification. I don't really care how quickly we do it. In fact, no matter how quickly we do it, we can always do it a little bit quicker, and that's good. But my specification, if I want to look at the bad stuff, I'll make the bad stuff red here. The bad stuff over here, it's really only on one side, right? These are the things that take too long. All right, now let's look at a different case. A different case, maybe something like this might be handle time or average handle time, AHT, where, yeah, we definitely don't want to take it too long, but there are some cases where we don't want it to go too quickly either, because if we're going too quickly, it means we're not really treating the customers well. Especially if it's an outbound sales call, we want to have at least some time that we have the company or the person on the line. Okay, hopefully that makes some sense. In manufacturing, you often have two-sided specs because you don't want to make it too, like let's say you're making something like a plastic comb or something like that. You don't want to make it too long, but you also don't want to make it too short. So you have double-sided specs. All right, those are obviously more complicated. We'll cover mostly the one-sided spec situation, but we'll go over one example where we do have two-sided specs. All right, just a very quick notion. What if you don't have any specifications? Well, the most important thing would be to go to somebody and ask to get them. That would be very helpful. All right. However, if you can't do that, here's one way that you can do it. You can resolve to make them up later, or to get them later, but for now, let's make up something that's reasonable. For example, somebody might say, well, we don't know exactly what the specifications are for turnaround time in this particular department, but it sure would be nice if it were 1 day or less. Okay, great. Use 1 day. Or, you know, we don't want people waiting in this waiting room. I could go around and ask them how long they want to wait. You know, a reasonable answer might be 0. Another reasonable thing would be to say, well, if I were waiting in that line, maybe, or in that room, maybe I wouldn't want to be more than 10 minutes or something like that. Great. Go with 10 minutes. The key thing will be at the end of your project, keep the same number so you can make that comparison. Oh, you know what? In the beginning of the project, 30% of the people waited longer than 10 minutes, but now that we finished, only 2% of people wait more than 10 minutes. Great. That shows real improvement. Hopefully that makes sense to you. All right. Whoops. There we go. Okay. One also little small comment on slide 98, and it's often confusing to people, is that I've been talking about getting away from averages, but what if you're already measuring a defect rate? A defect rate already counts the percentage of defects. So in that case, if you're looking at defect rate over weeks or months or something like that, you can average the defect rate, and it does tell you, in most cases, almost all cases, it does tell you essentially the percentage of time that you're getting it wrong. All right. So now here we go. So we're going to take a slight turn into this. Now we're going to get into the nuts and bolts. So how do we do it? How do we actually calculate it? And we'll do some examples. So the two cases, I hate when it does that. The two cases for calculating capability are, number one, when you have a lot of data, and number two, when you don't. Okay? So when you have a lot of data, it's usually very straightforward. You simply count. Count how many are in, count how many are out. If you're looking at, you know, for example, time to transfer somebody from to a different hospital when you're in your hospital, you might look, let's say you have a specification of 2 hours. You might want to say, what percentage of time do we make it 2 hours? What percentage of time do we not? And just use that straight calculation. Now, what do we mean by a lot of data? Well, that's a great question. Here's the way I take a look at it, or here's the way I think about it. If I'm confident that if I took another data set of the same size, I would get something very, very similar. By that I mean maybe within 1 or 2% of what I got, I'm good. I'm ready to go on. If I'm not that confident, if I said, you know what, if I took another data set, I might get a 30% different number, then I might want to get some more data. All right, let's take a look at this later. We'll very soon we're going to define something called a confidence interval, and that's going to help us out with that question. Okay, so let's do the number one when we have a lot of data. Very straightforward. We simply count. Capability is how many are outside the spec divided by how many are outside plus inside. Okay, that's if your glass half empty. If your glass half full, if you're going to say how many times we meet the spec, we'll say how many are inside divided by the total. All right, let's go over the example in the file invoices. In this case, we had a Six Sigma team, and they pulled together all of its collection data from its accounts receivable, and they looked at the times to collect. How long did it take them to collect the invoice in days? Now, since the last process team. Now, they had a specification. Maybe they had net terms of net 20 days, but in any case, it should be fast. But in any case, the team had a specification that collections were supposed to be less than 20 days. Okay? Let's look at what the current probability or process capability is for this. So to do that, let's go to the data set. And this is invoices. And we're going to do this in a couple of different ways. Number one is we could just do it straight in Excel, and we could put, we'll just count here. And if we can just put in an if-then statement. So I'm going to put in, I'll do it very, very big so you can see it. Okay, so equal if this guy is greater than 20, I'm going to call it a 1. Otherwise, I'll call it a 0. Okay, you'll see what goes on after this. Hit the return. And I'll just copy that all the way down. So there it is. There's 10,001 cases. And now I'm going to count. So I'll just sum that. So my sum will be equal to, and the percent, I'll do the percentage as well. So the sum is equal to the sum of this. Okay, so 2594, and the total would be maybe equal to the count of all of these guys. It looks like there's 10,000. I'll call that count. So my percent bad would simply be equal to this divided by this. And if I want to put it in percentage, which I said it is percentage, there I go, 26%, a couple more decimal points. There we go, 25.94%. And that gives us our answer, okay? So that's one way of doing it. The second way of doing it, we already know, is from Excel Stats. So let me open up Excel Stats. I'll close this down for just a moment. Get to the desktop. Okay, so here it is. I'm going to go into Excel Stats, and we'll just do collection times. I've got one num. So there we go. Oh, wow, look at all that. That's a lot. Go to my Summaries tab. Here's my I'll blow this up a little bit so we can see it a little better. I'm going to put it in percentage terms. There it is right there, percentage terms. I'm going to go from 0 to, it looks like 120. Okay, that's good. And one thing I can do is simply have 12 classes. That'll make, there it is, everything less than 20 right there. You see that, which is good. I can make it a histogram if I want, make it a little bit easier to read. And in fact, I'll even do 6. So that makes it simpler for me. And I'm going to show the values. And there we go. So it says 73.97% less than 20. I think I said 20. So there we go. You know, that's 1 minus our answer that we got before. So that's another way of putting our, what is this, 73.97. So what is 73.97? We'll have 100, and I want to subtract that. I want to get it in the same thing. And you see, there it is, basically 26%. Now, what's the difference here? The difference here is essentially how it counts, you know, what's less than and what's greater than exactly equal to 20. That's what's going to make the difference. But again, not that much of a difference, so I'm not going to worry about it too much. Okay, let's now do it in Minitab. So Minitab will be a little bit more difficult. Ooh, goodness. Copy this. Put it into Minitab. How that got back up there. All right. And Minitab has a couple of different ways that we can do this, which is good. But let's do the capability way, because we'll come back to this a little bit later. So if we're doing this in Minitab, one way that we can do it is go into Quality Tools, Capability Analysis, Normal. Okay? Now I know it should be in Graph, but it's in Capability Analysis, Normal. And if you don't get this and you don't have Minitab, you can just fast forward a little bit. Put in our collection data, subgroup size. Without worrying about what that is, we're going to put in a 1. And we don't have a lower spec, but we do have an upper spec of 20. It's not a boundary. Okay, so if we do this and just click OK, we'll get a bunch of stuff. And this is one of the reasons I don't like Minitab so much, is it gives us so many things. All right, so for example, it gives us this process data within, without, all that kind of stuff. It gives us a normal curve fit. I'm going to get rid of some of this stuff. There we go. But this picture really tells 1,000 words. You can see there's our friends KP or CP and PP, CPK, PPK. Let's not worry about what those things are. Get rid of them. And then we have expected within performance, expected overall. Get rid of that for just a moment. And there we go. Finally, there's our observed performance. So basically, unfortunately, what it tells you is parts per million, less than the lower spec, parts per million greater than the upper spec. So it says 259,400 parts per million. That's 24.9%. I'm sorry, 25.9%. So if you don't like that, if you do a Control-E that gets us back to this, and you click on Options, you can put it in percents instead of parts per million. I'm not going to do all this stuff either. You know what? I'm going to leave it all there, and we'll get rid of it again, just like we did before. But now I've got my percent, and that tells me the percent above that. So that's how you can do it in Minitab. Nice. I like that picture. It's a good picture. Okay. So now we basically know how to count. Remember when we basically know how to count. I think we knew how to do that before. Okay. So remember, when we do that, it's essentially just count. We have to have the specification, and when we have a lot of data, in this case we had 10,000 data points, we simply look at how much is greater than a certain number, how much is less, and report that. Pretty straightforward. Okay. Now let's get on to what happens now if you don't have a lot of data. And what we're going to cover is we're going to cover normal distributions. Now, later in this week, you're going to get, or later in the lectures, there are going to be some where we're going to cover a few more distributions, Weibull, log normal, and exponential, which covers a lot of material. If you have something that's more or less normal shaped or bell shaped, you can use this when you don't have a lot of data and you want to get a better answer. Okay. Now, what do we mean by the normal curve? Well, it's really just the bell curve, okay? It looks like this, like Dolly Madison's hair there, okay? And what we're going to do is we're going to use the notation. If x is our variable, whatever we're measuring, average handle time, we'll call that x. Discharge time, we'll call that x, whatever. If it looks like this, if its histogram looks more or less like this, we'll characterize it by this, using this notation. It's normal with a mean of mu, that's the Greek letter mu, and a standard deviation of sigma. And yes, that's related to the process sigma that we're going to talk about. Okay? Here's a couple of things that are kind of interesting about the bell curve. If we look at, for example, what's in between plus or minus 1 standard deviation in a bell curve, there we go. If we look at what's in plus or minus 1 standard deviation of a bell curve, it turns out that within plus or minus 1 standard deviation, that this area right here represents 68% of the total population. 68% of the total population falls between plus or minus 1 sigma. If we look at plus or minus 2 sigmas, right, and I'll color that, I don't know, light blue. If you look at everything within the light blue area, it turns out that that's 95%. And if we look at everything within plus or minus 3 sigmas, which I'll use green here, so that's 2 sigma, mean plus 2 sigma, mean plus 3 sigma. Okay. If we look at all the stuff within 3 sigmas, plus or minus, let's call that 3 sigma, the green is 99.7%. So almost all the variation is within plus or minus 3 sigma if the process is normal, if it's acting, if it's normal and if it's in control. Now remember when we had the thing about control charts and we talked about 3 sigma limits? This is part of Dr. Schuhart's reasoning, that he said that if a process really is in control, we're only going to get an out-of-control signal 3 out of 1,000 times, which is pretty rare. I can live with that. I can live with chasing my own tail 0.3% of the time, okay, which isn't very often. I'm wasting my time about 0.3% of the time. Okay. Anyway, those are just some characteristics of the normal distribution. All right. Now our capability problem in each case is either to solve for finding everything that's below and above, or everything that's above. All right? So basically, our problem is to say, what's the probability of a defect? Okay, now unfortunately, calculating that is not a trivial matter. Statisticians have done this for us, and to do that, we need a special case of the normal distribution called Z. Now, what I'm going to do is I'm going to show you how to do this at the end of the lecture, so that this is what used to be the standard when I had to go through this, 15, 20 years ago. You had to use the standard normal tables. Fortunately for us, we've got a lot better. Now we have Minitab, and we also have Excel stats, which is going to do it for us. So let's go through a couple of examples where we're using Excel stats, and we'll come back to this later. Okay? Now, to do it, okay, so what we're going to be doing is we're going to be using this example that's given on slide 110 for emails, and hopefully this is something that everybody can relate to. Let's suppose that I had a personal goal of limiting the amount of the number of emails I got. Okay, and this seems like a long time ago that I had less than 60 emails, but okay. I would say that suppose this has 60 days. For 60 days, I collected my emails, and I counted the number of emails I received. And what I wanted to say, or what I wanted to maybe say is, let's suppose that I said a bad day was more than 40 emails. That I didn't want to lose productivity by getting more than 40 emails I had to deal with. That seems a very small number these days. Essentially, however, what we're doing is we're defining it such that our upper spec, right? Our upper spec is 40. We're drawing a line here, and this is what we're looking for, right there, percent bad. Okay, so this is what we've got. Now, you might say, well, 60 days, that's a lot of data, so I can simply count that, and we're good. Okay, that's one way of handling it, but I'm not so sure I'm confident of that, so I'm going to use an alternative method, and I'll show you how that method goes. Okay, so let me erase all this. So what I'm going to do is I'm going to open this in Excel Stats. And there's my data. And as you can see, it's one num. And so I'm going to go to one num, replace that, and I'll put the old 10 back in there. So the first question I want to ask is, if I were going to count, which I guess I could, right? I want to count how much is greater than 40. I could go to here, and it looks like my greatest is 50, and my least is 10. So if I went from 0 to 50, which I could do, I might want, I want to look at maybe 10 classes, 0 to 50, and that didn't do it for me. Why? Oh, I'm looking for the intervals. Oh, I see. There we go. Okay. So this would tell me essentially what percent of the time I was above I got above 40 emails. And it looks like it's about 6.67%. Okay. So that's just by counting, and that's what we've done before. So now I'm going to show you a second way of doing it. So the second way of doing it is to first take a look at the histogram and say, hey, does this look more or less normal? And in this case, I would say, yes, it absolutely does look pretty normal to me. It looks like a bell curve. And again, if I made maybe even more classes there, it stays up. It holds the scrutiny. It looks still to me like, at least to me, it looks more or less like a normal curve. If I were going to draw a curve, that would probably be the best curve that I could draw for this one. Okay. Now keep in mind, when you don't have a lot of data, it's not going to fit exactly. So that's number one. Number two is that there is another tool besides the history. That's pretty interesting what it did there, isn't it? Not sure why it did that, but that's pretty cool. Okay. There is another tool that we can use, and it's in, I believe, Extra Tools. Yeah, there it is right there. A normal probability plot. And a normal probability plot is something that I evaluate by looking to see whether or not this looks like a straight line. So it does something to the data to make it so that if it's normal, the data will go from least to greatest in a straight line. And what you're most interested in is that center area, if that looks curved or not. And to me, it looks pretty darn straight. It looks pretty darn straight. Okay? So if it looks like that, then it's good to go ahead and calculate the capability. Now to do this, what we're going to do is we're going to note two things. Number one, we're going to note the mean, and number two, we're going to note the standard deviation. So I'm just going to write that down on a piece of paper, 24.9 and 9.656 as the standard deviation, mean and the sigma. Okay? And now I'm going to go to something called PDF. Okay? So PDF is going to be your friend. If you go to normal, see how it has all these things on the bottom, all these different tabs. Let's click on normal. And then what we're going to do, that looks like Poisson to me. Let's click on the normal tab. All right, there we go. And you can see it has a normal distribution, but it's not just any normal distribution. It's a normal distribution with a mean of 10 and a sigma of 1.2. We're not interested in that. We're interested in a one that has a mean of 24.9 and a standard deviation of 9.656. There we go. And let's make it go from 0 to 60. Okay. And now what we want to do is we want to look and see what percentage is going to be less than or greater than 40. So we'll put in 40 there. I'm even going to shade that probability. And there we go. That tells me essentially what percentage is below 40. And it says that below 40 is 94%. That's that right there. And above 40 is 5.8%. So in this case, the normal model actually fits our actual data that we had, which, if you recall, was around 6%, 6.67%. This says, using the normal model, which is a little more robust, 5.9%. To me, 5.9 and 6 are just about the same. All right, let's do this example. So basically, that's it. So to do a recap, what are the things that you need to do in order to do in order to use Excel stats? That's not what I want to do. Let's go into here and this. There we go. Okay. So if we recap that, the first thing that we want to do is we want to, if we have the data, plot the data. Remember, you should have already done this, but you can do a histogram or a normal probability plot, or both. Remember, here you're looking for a straight line. And this is just telling you, essentially, is the normal okay? Number two, go to PDF, and this would be in, say, OneNum in Excel stats. Number two, you want to go to PDF instead of OneNum, and normal, and put in the mean, X bar, the standard deviation, S, and then your spec. Okay? And you get those from OneNum, right? You're gonna snag I'll just put it in there, snag X bar and S from that. Okay? and you're going to look at probability, and that's the capability. That's it. The thing also I like about Excel stats is, hopefully that makes sense to everybody. All right. So the thing I like about Excel stats is, if I take a look at PDF, is it gives me a nice picture here. It really does give me a nice picture of how much is below and what the probability is. So that's kind of cool, right? And you'll notice that this is where I typed in the mean and standard deviation. In one num analysis is where I looked at the histogram and I took the mean and standard deviation. On the extra tools is where I did the normal probability plot. Okay, that's Excel stats. Now let's go ahead and do this in Minitab, because you can skip ahead if you don't have Minitab. But let's go ahead and do this in Minitab, because so that's Excel stats. We'll just move that away. Let's go ahead and do this in Minitab, because some of you actually will be using Minitab, and Minitab has a fantastic version of probability plots. So there's two different ways of doing this in Minitab, sadly. The first I've already shown you. I'm going to show you again. It's this: quality tools, capability analysis, normal. This time we're going to do email, subgroup size of 1. I'm going to put in my, I don't want the within. I'm going to put percents. All right, and click OK. And my upper spec is 40. And I'm just going to go ahead and click OK here. And notice it does give a normal model, so you can look very quickly and see, does this normal model fit pretty well? You can see it fits pretty darn well here. There's my PPK, don't want that. Notice I didn't get the within this time. And one other nice thing about this is Minitab gives you the observed. Remember that 6.67 that we got before? That's by counting. So if we just count, that's 6.67. But our expected, a more robust one, that's based on, the first one is based on the histogram just by counting. The second one is based on that red line, which is a fit of a normal distribution to our histogram. And it says that that's 5.89. So in this case, both of them give pretty good results. And since we don't have a lot of data, I'd be using that expected overall performance. So pretty good. I really like how Minitab does that. And it's pretty quick, right? Gives you both of those things. So that's pretty good too. All right. Now, Minitab also has another way of doing this, which I actually like a lot. I'm going to show it to you, but again, this is extra stuff. I really love probability plots. We'll talk about them very soon. But probability plots are excellent. So if we do a probability plot, we'll also be able to see the capability. So let me go ahead and click on single probability plot. I'm going to do for emails. And you'll notice you can do probability plots. Minitab has a great function where you can do them for all sorts of different distributions. We're only interested in normal right now. So go ahead and click that. And if we do that, you can see Minitab not only, this should look like Excel stats probability plot, but it's a little bit, it's a little bit nicer for sure. Gives you the mean standard deviation, which is helpful right on there. But it also shows you a confidence interval on that fit, which is pretty cool. So you can tell actually that if the dots are within that confidence interval, the upper, the two blue lines here, I know I'm having a hard time selecting them alone, but which ones am I talking about? I'm talking about this one and this one right there. If it's within those, it's a pretty darn, it's a pretty darn good fit. Now, a lot of times the points at the very end are going to waver from that a little bit, but in this case they don't. Anyway, it's not of major concern. It also gives you something called an AD value, which stands for Anderson-Darling, which is a statistical test of normality. I'm not too big on that, but essentially I love looking at plots and trying to understand it via that. But essentially what that AD value is telling you is that, yeah, the data are pretty normal, or normality is a good model for them. Okay, so how do we go from here to a capability? It's actually pretty straightforward. So if I do a Control E, puts me back here, and I'm going to go to, I believe it is Scale, and I can actually put on reference lines, and I'm going to show a reference line at a Y value of 40. I don't want to be more than 40 emails. Whoops, I'm sorry, at data values. I don't want a Y value. I want data values. Why? I don't know why they don't have the axis here at 40. By the way, if you get it wrong, no harm, no foul. You just do another one in Minitab. And here it is. It puts a reference line there, and it lets me kind of look over and see how much I'm over. And now I think I screwed up because I put in a reference line, and all that's great. But what I really want is for Minitab to tell me the percentile. So here I go. So I'm going to do that, percentile lines, and I'll show the percentile at 40, and you'll see this is even better. Yeah, check that. There it is right there. It says the percentage, and it gives me the percentage below. It doesn't give me percentage above. 94.1%. So again, 6.1 or 94.1 would be 5.9%, which matches our other data that we had before. 5.9% bad. 5.9% of the time, I get more than 40 emails. Make sense? Hopefully it does. And I'm going to get rid of that reference value because I don't need it. I don't like those two 40s on there. Let's just take the one. Okay, so there's essentially the multiple ways of doing it. In Minitab, we can either go to Stat, Quality Tools, Capability Analysis, Normal, or we can go to Stat, we can go to Graph, Probability Plot, and do it that way. All right, so those are the two different ways of doing it in Minitab. Whew, okay, so we got a lot of traction out of that one example. However, let's go through one more example here. Suppose we had a two-sided capability. I want to show you how to do that in both Excel Stats and Minitab. Again, Minitab is going to be pretty straightforward, but Excel Stats is what most of you have, so we'll cover that pretty well. All right, the key thing is we're just going to do it separately and then add them together, right? So what if you had a two-sided spec? That would be the average time, handle time example. Don't want it to be too small, but we don't want it to be too long either. If it's too short, that means we're not really treating customers well. If it's too long, it means we're just kind of dawdling on our calls. Okay, let's go through the same. Let's go through the same example. And suppose I had a lower spec of 10. I don't want to be too busy with my emails, but I don't want to be too lonely either. I want to make sure that people are still contacting me. So suppose I had a lower spec of 10 as well. All right, so let's go ahead and, by the way, the first steps are exactly the same. So let's go ahead and do this in Excel Stats first. There's my emails. So remember, the first steps are plot the data using one num. I'll look at the histogram, and I'll look at the normal probability plot, and I'm looking for whether it's a straight line. And then I'm going to snag or keep the mean and the standard deviation. Then I'm going to go to PDF, normal, put in the X bar S and my spec, and look at the probability. Okay, so that's what I'm going to do. Remember, just to quickly repeat the first part, because just to remind people, I did the histogram. Yep, looks pretty normal. Then I did my normal probability plot. Yep, looks pretty normal. That looks pretty straight. Okay, so I'll shut that down because I don't need it. And I'll come back to here. So I'm going to snag 2.24.9 and 9.656. And I'm going to go to PDF, normal. There we go. Okay, now I can enter in my 24.9 and my 9.656 into that. And now I have my specs. But uh-oh, I can't enter both. What I could do is I could enter one at a time. First get this one. There's my 40. And it says that the percent greater than is 6%. And now I could enter in my 10. And it says that the percent less than 10 is 6%. So 6% plus 6% is 12%. But Excel Stats actually has a way that's a little bit easier. Notice how I had to do both of those. It can do both at once. So we're going to use that. So if we go to Excel Stats, both, you'll notice if I click this little blue arrow, I go back and forth, click the extra tools, and this actually allows both. So I'm going to show A, B, C, D. Fine. No, I'll just show the probability. So here, I have to define my regions. So I might want to have my first region be, oh, I don't know, let's say minus 20. It's going from minus 20. So minus 20 to 10. I know I can't get minus 20 emails, but that takes care of all that. And then from 40 to, let's just say 60. Okay, so there it is right there. It's showing both of those regions, and I'm just going to go from 0 to 60, and that's my plot right there. And that really shows me both of those. It calculates them separately. You see that, and says my probability is 12%. So it did both at once. Again, if you don't want to use this tool, you can just use the previous tool, this one, 2 times, note what you have, and write it down, add them together by hand. Okay? So that's Excel Stats, doing it in two different ways. Now let's go into Minitab. The first one would be this. If I do a Control E, all I have to do is add a second reference line, or I'm sorry, percentile line. I'm going to add one at 10. This one is nice, but you've got to add them both together. And again, you'll see that it tells me this is the percentage less than 10. It says it's 6% less than 10, 6.141 to be exact. And I have to take 1 minus 94%, 94.106% to get what's above. And again, that's about 6, and 6 plus 6 is about 12%. So it gives me the same answer. One last time, if you're going to use the other Minitab function, which is capability, stat quality tools, capability analysis, normal, you simply have to add the lower spec, and there you go. This tells me the percent below, and this tells me the percent above. Now, the interesting thing is that Minitab will keep going below 0. You see that? So it does give you a slightly different answer. It gives you an answer of, I'm sorry. Totally wrong. That's the observed. That's the observed, and that's the expected. Sorry about that, folks. And the observed is, there actually were 8.33% below 10. However, if we're going to use our normal model, 6.14% below, 5.89 for a total of 12.03. All roads lead to Rome. Let's get rid of that PPK, and we're in good shape. All right, that's it, folks. Those are the 3 ways of doing this. 2 of them were in Minitab. 1 was in Excel Stats. So pick your favorite way, go with it, and that should work. Okay. Now, just as a recap to all this stuff, remember that there are 2 cases. If you have a lot of data, just count. Counting should be pretty straightforward and pretty close to being right. If you don't have as much data, you should look and see if a normal model works. If it does, great. If it doesn't, we'll be using the techniques later, and you'll be able to see which techniques work when we do probability distributions, which you'll also be able to look at and listen to that lecture. Remember that capability is how often we get it right, or conversely, how often we get it wrong. If you really get stuck and you don't have a lot of data, call a statistician or call a master black belt, and they'll be able to help you. And you know, I'm just shocked with how many people, when it comes right down to it, simply don't count and say, here's what it is. And you know, a lot of senior managers are pretty comfortable with that. Okay, so I want to do a couple of examples. We'll do one more example, and we'll do HR. We'll do this HR example of finding candidates. And suppose on slide 125, suppose a Six Sigma team was working in HR and they wanted to reduce the number of days it took to identify a qualified candidate, or a number of qualified candidates. They properly collected what they called identified times data in days. So the idea would be maybe for a specific position or something like that, they had a number of people who they needed to hire, and so it looks like I closed it down. I did. That's not helpful. Okay, so let me go back to I'll go to my pen. And so they had a project, a DMAIC project, and we're looking at the time. It's identify times. It's it. Okay, and they want to baseline it, right? It says we have an upper spec of 60 days. It takes us more than 60 days. That's not so good. We want to see how often we do that. Okay, and we want to estimate the current process capability. So let's take a look at the data that's in HR Find Candidates. All right, so let's see. Whoops, I'm going to erase these drawings. There's HR Find Candidates. And let's do it in Excel Stats. So we're going to do one num analysis. Replace this. Well, first thing, if we look at the histogram, well, first of all, we only have 20 data points, right? So we should know that maybe that's not enough simply to count. But if we were going to count, let's go ahead and do that. Let's see what percentage of time we're above 60. All right. So it goes from this to this. So I don't know what happens if we go from 0 to, let's go from 0 to 90. Just for giggles, I put that in. And we'll put 3 of these. Now look, how many are above 60? Well, one way we can do that is by putting 3 bars there and putting a percentage and showing the values. Oh, there's 0. Now here's a classic case of does that mean that our process is really at 100% capability or 0% defect rate? Well, for the 20 points that we looked at, the answer is yes. So the question is, do we really believe that, or should we make a better estimate of that? Well, one way we can do that is by using a normal distribution to do that. Okay? Now, should we use a normal distribution? I think that's, so I'm going to go down to 0 to 60 again. And maybe, let's go from, let's go 15 to 60. 15 to 60. And I'll go maybe a little bit above that, just to give us some separation on the bottom side. There we go. Okay, and I'll take off those values. All right, so should we use a normal distribution? Because, you know, I'm not sure. Maybe that's even bimodal. Well, one way that we can do is, remember, a histogram's not that great unless you have about 50 data points or more. That's a rule of thumb. So let's take a look at the normal probability plot. And sure enough, it's not so bad. That looks more or less like a straight line, especially in the center. It's a little bit curved, but not too bad. If we wanted to really look at this in Minitab, we certainly could, because Minitab would give us the confidence intervals, remember? So let's see, where's my data? HR candidates. There it is, identify time. I'll copy that, put it into here, and let's take a look at the probability plot of identify time. And sure enough, normal, while it may not be a perfect model, it's got a, it's going to get rid of a bunch of that stuff. There we go. Sure enough, while normal might not be a perfect model, it's certainly within those bounds. So I'd feel reasonably comfortable using normal as a model here. So let's go ahead and do that. There's our Excel stats. And remember, we're going to have to snag the, here's our one num analysis. We're going to have to snag the mean and the standard deviation. So I'm just going to write that down. 40.59. You know what? I'm just going to copy it. And we'll go to our PDF. And we're already in the normal. That's great. So I'll just, I don't know, put it right here maybe. Oh, did I screw up? I did, didn't I? Let me paste the special. I'll paste values. There we go, 40.59. 40.5. How about 0.6? And 10.6. Close enough, right? All right. And we'll go from 0 to, let's go 75. All right, that gives us a nice look on the plot. And of course, our value of the variables was 60. And there it is right there. It says that our probability of being greater than that, we're going to estimate is 3%, 3.3%. So 3% of the time, we would estimate, we will take longer than 60 days to identify the candidates. That would be the answer for that one. Okay, so that hopefully that one works for you. We found that this is that this then is 3.3%, and that's what comes out right there. I guess 3.4. All right, 3.3 or 3.4. Now let's also do the case where we have two-sided. Suppose we wanted to have we had a lower spec of an upper spec of 60, but we didn't want to take less than 30 days because that might mean that we're not doing a real due diligence on this stuff. Let's see what our capability is. Again, if we went to here and we counted, again, this time I'll just go from 0 to, keep messing up that way. If I go from 0 to 60, I have, let me just do 4 classes right here. 15, 30, and then there's the 60. I guess I'll go above 60, and I'll do 4 classes. What I do. Let's just do 3. There we go. So all this from 30 to 60 is basically my data that's good. Everything above it is bad. Everything below 30 is bad. If I put the show the values, it looks like 20% of the time I'm below 30, and roughly 0 I'm above. But of course, this is not necessarily a good model because this is what it would look like, if we're looking at the bigger picture. So, so let's see. So let's fit that normal distribution, and let's see. So to do that, we go to PDF. Remember this one, and copy this again. Go to Extra Tools, and there it is right there. I'll say the first thing I care about is minus, again, let's go to 0 to 75. I care about, say, from 0 to 30 first, and then I care about above 60. So I'll say 60 to 90. And there it is. It says that I'd estimate that this 15% below and 3% above. So those are my estimates. I add those together, and the total probability is 19% or 19.2%, which is that right there. Okay, so that's just adding the lower and the upper. Okay, and you can see that that's what we get in this one. It says 25, but there we go. There's the 30, so I'm not sure why that had the 25. Okay. All right, so so that's about it. Now, I did say at the end of this lecture I would go through the Z method of finding this. So for those of you who want to, we are done, and you can write in your view, what are the key takeaways of this section? What are the questions that you can answer as a result? And how can you support business improvement with this? However, for those of you who want to know the method that you may need to use, say, on a ASQ exam, let's go back to slide, we're going to go back to slide 113, and we're going to do our emails example again. So let's do that, and I'll do it the standard method. The standard method is to convert something into a Z-score. Now, if you keep in mind, I want you to keep in mind something here. Hold on just a second. I'm going to start up a program. Oh my gosh. There we go. I don't know how it got closed before. I must have clicked the wrong button. There we go. Right. Okay. There we go. So if you recall, this example was I have an output of number of emails. Okay, that's my spec was 40. Spec was equal to 40. Okay, remember that? Okay, so basically, what I wanted to show you was the following. If we go to our normal distribution in Excel stats, let's see if I can kind of get there. Here it is. Hey, nothing happened though. Oh, I get it. Oh, great. Okay, I had a crash on one of those programs, unfortunately. Let's just close down all the Excel. Sometimes happens when you have too many things open. All right, so let's close some of these. No. 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 Ugh. Okay, there we go. And in fact, I'm just going to close. Oh, cancel this. Okay, so here's my emails. Finally. Goodness gracious. All right. So what I want to show you first is that a normal distribution, it doesn't really matter what your mean and standard deviation are. It basically is going to look similarly. So in the old days, what we did was we moved everything to a standard deviation, to a mean of 0 and a standard deviation of 1. And I'll show you how to transform that. So that's the first thing that you do is you transform your data to everything is between a standard deviation of 1. I'm sorry, everything is between 0 is a normal of a mean of 0 and a standard deviation of 1. So I want to show you that. And just to keep in mind, we started out with 24.9 and 9.656, and we were interested in how much was above 40, I believe. Okay, so let me put in 0, 50, and we were interested in how much was above 40. Okay, and we found out that that was 5.893. So just keep that in mind as we go through what we're going to do. All right, so here's the method without getting too crazy about it. Looks like it closed down again. Not sure why, but it did. There we go. Okay, so here's the method as it's detailed on here. Okay, we're just going to do it by hand in Excel right here so we can see it all. So what I'm going to do is I take my, I call something Z, and it's equal to, I take my variables, it's my X bar, it's my spec minus the X bar divided by my S, okay? And that is equal to 40 minus 24.9 divided by 9.656, okay? And that happens to equal, I'll call this Z spec. That happens to equal 1.564. Okay, and it's essentially saying the following: what value is this 40 in the z world? If I made this go to a normal distribution with a center of 0 and a standard deviation of 1, where would 40 be? Would it be some, and this is my, would 40 be somewhat over here, or would it be over here? Where would the 40 be? So in other words, I'm taking out the units. So the answer is it's 1.56 is the equivalent of 40 in the z world. So if I do that, okay, I see what's going on. I think close up Minitab. Give me a little more space. Boy, everything's crashing. Okay, back here again. Okay, so let me go to PDF. Sorry about that, folks. Normal. 24.9, 9.656. And we found that it was 1.564, 1.564, right? Okay. So if I put in a normal with a mean of 0, a standard deviation of 1, and again, I'll make it go, I don't know, from -3 to 3. Take a look at that. And I put in 1.564. Notice what it gives me. It gives me that the area above that is 5.89%, which is exactly the answer that we had before. So 1.564 is the z world equivalent of 40 in the typical world that we had before. Notice how confusing this is? Yeah, but this is what we always used to have to do. All right, so how did we used to have to do it? Well, we used to have to look it up on a table. And here I've got one in Wikipedia. I've got a standard normal table, which I've given you a reference for. And you see it says here, the table gives a probability that the statistic is less than z. This equates to the area under the distribution below z. Okay, great. So if I go to 1.54, there it is right there, and it says everything below 4 is 0.9406. So again, just to do this before, there it is right there, which is essentially 9.4. So we get the same answer. All roads lead to Rome, but that's how you do it in the old world. You had to look it up on a table like this. There it is, 1.506, 1.56, and that's it. Okay. Anyway, I know that was painful. It was really painful to me. Now that we've done this, now you really have to spend a little bit of time. And in your view, what are the key takeaways of the section? What are the questions that can answer as a result? And how can you support business improvement with this section? Remember, we covered capability by counting, and then we covered capability when we don't have a lot of data, normal distribution. You can use Excel stats. You can use Minitab. Okay, take care.